Hello guys, my name is Devin. My YouTube channel is DRG Bros. Today we're going to be talking about the polarizations of complex numbers. Now, there are a lot of complex numbers and stuff, like I think pi, complex number, e is complex number, numbers like that. And so first, we're going to do a review real quick on angles. So let's just draw two angles here. Let's do an angle like that, and we're going to do a big angle like that, okay? We could call this length right here theta 1, and this length theta 2. Those are angles. So we all know what degrees are, and if you don't, then I feel very sorry for you. So radians are the same as an angle's size. So this length right here and this length right here, we can measure in radians. So we're going to do this. So we're going to consider the radian measure. We're going to draw an angle here, and we're going to want to find out what this distance is, okay? What we're going to do is we're actually going to turn it into a complete circle, and it's going to be a unit circle, okay? Sorry if that's not the best circle in the world. Now, we know that the circumference divided by the diameter of a circle is pi. That's the definition of pi. And so that implies that if we multiply both sides by d, we're going to get c equals pi d. We're moving the d to the other side, or multiplying both sides by d, however you want to do it, which implies we know the diameter is double the radius. So we can replace that out. C equals pi times 2 times the radius. Because if you didn't know, guys, so on a circle, the length around is the circumference. The length all the way across is d, and the length halfway across is r. Okay? But r is also radians, so yeah. Which we can then simplify that, which basically implies that the circumference divided by the diameter equals pi factors into the circumference is equal to 2 pi r. Alright? So we're now going to use that in our thing. But first, there's one more thing we need to do. This might not be a review, and I know it's not, but we're going to do it anyway. So what we need to do is we're going to show that on a unit circle, we can define the sine and cosine functions. So if we draw a unit circle, like this, sorry if that's bad, and we draw our 4 lines like this to separate the circle into fourths. If we draw a triangle like this, right here, you see? And so this is a unit circle. So this is 1. Then the bottom length right here is the cosine. The side length right here is the sine. And the angle is theta. Okay? Now, using the Pythagorean theorem, a squared plus b squared equals c squared, we know that c is the hypotenuse. So we can do that the sine squared of theta, because remember we're doing the angle here, plus the cosine square of theta equals 1. And I may have gotten that backwards, just saying. So, for any sized triangle, so let's say this triangle, we can draw a smaller triangle inside it with a length of 1. The angle is theta. This shows that this is the sine and this is the cosine. Now, these triangles are similar. So what a similar triangle means is the dimensions are proportional. So if we have a triangle here, say with side lengths 5, 3, or 4, and 3, like this, we could then have a triangle that's double the size by 10, 8, and 6. In case you didn't know, these are Pythagorean triples. And these are similar triangles because the sides are proportionate to each other. So we're going to use this. So because of this, the opposite side divided by the hypotenuse is equal to, so in case you didn't know, the opposite side is this side, and the adjacent side is this side, okay? So the opposite side divided by the hypotenuse is equal to the sine of theta divided by 1, and theta and 1 kind of just fades away. So we have the opposite side divided by the hypotenuse is equal to the sine of theta in this triangle. We also have the adjacent side over the hypotenuse is equal to the cosine of theta for the same reasons. Just go to the new page. Got it. So what we're going to do now is we're going to plot a complex number. So we're going to draw a graph, like so. Okay? And let's say that in area 2, a complex number is up here. Like, we're going to show how to plot this. Let's say a complex number lives right here. Okay? Right here on the spot. R is equal to a squared plus b squared, and z is equal to a plus bi. Okay? What we're going to do now is we're going to start replacing. So we're going to do the square root of a squared plus b squared times a over the square root of a squared plus b squared plus b over a squared plus b squared I in parentheses, which is equal to r, the cosine of theta plus the sine of theta I. And if you remember from the last video that I made on Euler's identity, we know that this is equal to e to the I theta. So this means that it's equal to r e to the I theta. That's how you graph it. That is the polar representation of a complex number. Thank you very much for watching this video. I hope you guys enjoyed. Please subscribe and check out our other channel, DRG Brothers Learning. We'll see you for another video. Bye, guys.